Hello, our today's topic is about conjugate of a complex number. Now, here we are supposed to write the conjugates of these two complex numbers, 4i minus 2z, 4 minus 2i, and 3 plus 5i. So, what is the conjugate of a complex number? If we have a complex number z, which is represented as x plus yi, we know that this is the real part of the complex number, and this is the imaginary part of the complex number. Then the conjugate of z is written as conjugate. Okay, conjugate of z is written as z bar, which is equal to x minus yi. Okay, for any complex number x plus yi, its conjugate is z bar. This is equal to x minus yi. If we proceed, if we are supposed to find again the conjugate of this, again we put another bar. This is going to be x minus y. Okay, this is again x plus yi. This is to mean the conjugate of a complex number is the number itself. Okay, the conjugate of the number, the complex number, is the number itself. So, how do we find how do we find the conjugate of this complex number a? Okay, now a, our complex number, let's say z1, is equal to 4 minus 2i. So the conjugate of this is z1 bar. This is equal to 4 plus 2i. 4 plus 2i. And in case of b, okay, suppose we have z2, which is 3 plus 5i. The conjugate of this, is equal to 3 minus 5i. The conjugate of this number is 3 plus 3 minus 5i. But just to make sure, okay, what is the conjugate of z bar? Okay, the conjugate of again z. This is the conjugate of z. Now here we have the first conjugate, which is this. Okay, the second conjugate is making this plus 3 plus 5i. Okay, which is equivalent to the complex number itself. Now here it's better to add. Okay, it's better to add the modulus. Well, here the modulus of complex numbers. Okay, for any complex number z, which is represented as x plus yi, the modulus of this complex number is represented as, okay, absolute value or modulus of z, which is equal to r. This is equal to the sum of the product of the squares of the real and the imaginary part under square root. Okay, r, which is called the modulus, is equal to square root of the sum of the square of the real part and the imaginary part square. So for a, here we have a z1, which is 3 plus 5i. Okay, 3 plus 5i. Then now modulus of z1, which is equal to r1, is equal to square root of 3 squared plus 5 squared. This is equal to, okay, square root of 9 plus 25. This is square root of 34. This is r1. Modulus of the complex number z1, which is 3 plus 5i. And the modulus of b, okay, the modulus of, let's say, z2 is equal to 4 minus 3i. Now the modulus of this Z2 is equal to R2, which is equal to the square root of, again, 4 squared plus negative 3 squared. Now this is equal to the square root of 16 plus 9, which is the square root of 25. This is 5. The modulus of this complex number is 5. But what is the modulus of this? What is the modulus of complex numbers, let's say Z3, which is 1 plus root 3i divided by 1 minus root 3i? Here, it's impossible to see or to have the imaginary and the real part. No imaginary part, no real part, because the denominator is also a complex number, which is somehow irrational, okay? Irrational in other concepts of mathematics. So here we have to use the conjugate of this to simplify or to separate this number into the real and the imaginary part. The real and the imaginary part. Let's see how we do this. As we know, the conjugate of 1 minus root 3i, okay, the conjugate of this is, okay, the conjugate of this is 1 plus root 3i is the conjugate of this. So to avoid the complexity, okay, we know that 1 plus root 3i, okay, divided by 1 minus root 3i times 1 is the same as Z3. And on the other hand, 1 plus root 3i divided by 1 plus root 3i is equal to 1. Now 1 plus root 3i is the conjugate of 1 minus root 3i. So if this works, okay, if this is true, okay, we know that this division gives 1. Multiplying a number by 1 doesn't change the number. So that now Z3 is equal to 1 plus root 3i, okay, root 3i divided by 1 minus root 3i times 1 plus root 3i, okay, divided by 1 plus root 3i, okay, root 3i. Now the product, okay, the product is simply 1 plus root 3i times 1 plus root 3i, okay, divided by 1 minus root 3i times, again, 1 plus root 3i. But do not forget that I is equal to square root of negative 1, implying that I squared is equal to negative 1. I squared is equal to negative 1. Now, the multiplication goes, okay? The multiplication goes. 1 times 1 is 1, okay? This is 1. 1 times 1 is 1. And 1 times root 3i is plus root 3i. The second step is root 3i times 1 is plus, again, root 3i. And again, root 3i times root 3i is plus root 3 squared, okay, root 3i squared, okay, squared. And here, 1 times 1 is again 1, okay? And 1 times root 3i is, okay, 1 times root 3i is root 3i. And negative root 3i times 1 is minus root 3i. And negative root 3i times root 3i is negative root 3i, okay, negative root 3i squared. Okay, the negative is a coefficient in this case. Okay, let's go. Okay, this is Z3. Now 1 root 3i, so this is Z3 is equal to 1. Now Z3 is equal to plus 2 times root I, 2 times root 3I, okay, 2 times root 3I. Now this is going to be plus root 3 squared times I squared, divided by, now this is cancelled out, root 3I, negative, positive. So 1 minus, this is again going to be root 3 squared times I squared. Here we said that I squared is negative 1. So this is going to be, okay, this is going to be out of the square root, and here we have negative 1. So this is 1 plus 2 square root of 3I. So this is going to be plus 3 times I squared is negative 1, divided by, and again 1 minus, now it will be out of square root 3, then this is negative 1. This is negative, I squared is negative 1. Okay, now this is going to be, okay, 3 negative, okay, negative 3. Here we have 1 minus negative 3 is going to be negative 2 plus 2 square root of 3I divided by, okay, this is 3I divided by, this is going to be positive, so divided by 4 is Z3. Now this is to find the modulus, okay, the modulus. Now Z3 can be expressed as negative 2 over 4, okay, negative 2 over 4, okay, plus 2 square root of 3 over 4I. Now Z3 can be split into real part and imaginary part. So the modulus of Z3 here, the modulus of Z3, which is equal to R3, is equal to the square root of the real part squared, negative 2 over 4 squared, plus the imaginary part squared, okay, 2 root 3 over 4 squared, okay. This is the modulus of this number, okay. This is equal to, now this is 4 over negative 2 over 4 squared is 4 over 16 under square root, okay, 4 over 16 plus, because the negative is going to be positive. Now here we have by 2, or this is 4 times 3 over 16. 4 times 3 over 16 is 12 over 16. Now the sum of the two, okay, the sum of the two goes 16 over 16. The sum of the two goes, this is equal to square root of 16 over 16. This is equal to square root of 1, which is equal to 1. So the modulus of this complex number, is 1. Thank you for watching. This is Ahatube, your partner in academics, especially in physics, maths, and chemistry, and engineering courses. Do not forget to like, share, and invite others to see this video. You can find me on Google. Okay, you can find me on Google here, www.youtube.com, okay, .com hash, okay, at Ahatube24. This is on Google. Okay, this is on Google, and on YouTube, okay, on YouTube, you are simply supposed to put at, okay, at Ahatube24, okay, in the search after the search method. So you can write your the topic you need, and you can see everything here. So thank you for watching.